the last program, we looked at two vectors which did not meet at a right angle. We found the ordered pair for each vector, added them together, and got the ordered pair of the resultant. The two starting vectors, serving no further purpose, were discarded. We now had the horizontal and vertical components, which allowed us to calculate the magnitude and direction of the resultant. Now let's get really adventurous. Let's add three vectors together, A, B, and C. First, we'll add them using geometry. Slide A and B together and label the resultant G. Now slide C over to the end of G. So the resultant R is the sum of all three vectors. Sliding vectors around is simple in animation, but on paper things don't slide so easily. We need a better method, and ordered pairs are just the thing. Here's where we started, A, B, and C. Let's find their ordered pairs. A is 4 over and 4 up. B is 3, 0, and C, 0 minus 9. Now we just add them to find the resultant. 7 minus 5. And here it is, 7 across and 5 down. But have we done it correctly? Let's check. So ordered pairs allowed us to find the resultant without actually having to move vectors around. Any number of vectors can be added if their ordered pairs are known. Here, the resultant vector will be 7, 9. Of course, if we'd taken the trouble to draw all 5 vectors, the resultant could be found. But why bother when adding ordered pairs is so quick and easy? Up until now, we've been resolving vectors on a grid. We simply counted. But even without a grid, we can still resolve vectors. All we need is a couple of new tools, sine and cosine from trigonometry. In this next example, we're going to find the components of a vector when there is no grid. We'll call the horizontal component H and the vertical component V. To find the magnitude of the horizontal component, we'll use the cosine ratio, which is the length of the adjacent side divided by the length of the hypotenuse. So, adjacent over hypotenuse, or the magnitude of H over the magnitude of A, equals the cosine of angle theta. Multiplying both sides of the equation by the magnitude of A and simplifying, we get the magnitude of H equals the magnitude of A times the cosine of theta. The magnitude of A cos theta is the horizontal component. Now for the vertical component. Instead of the cosine ratio, we'll use the sine ratio, which is the length of the opposite side divided by the length of the hypotenuse. So, opposite over hypotenuse, or the magnitude of V over the magnitude of A, equals the sine of angle theta. Therefore, the magnitude of V equals the magnitude of A times the sine of theta. The magnitude of A, sine theta, is the vertical component. So, we've resolved vector A into its components. Now let's put in some numbers. If we make A 8 units long and angle theta 34 degrees, we can find the actual values of the components. The horizontal component equals 8 times the cosine of 34 degrees. 8 times 0.829, or 6.63 units. The vertical component equals 8 times the sine of 34 degrees. 8 times 0.559, or 4.47 units. So the ordered pair for vector A is 6.63 units, 4.47 units. For the first time, we've taken a vector with known magnitude and direction and resolved it into its horizontal and vertical components without having to rely on a grid. If we want to check our results, we can use the two components to verify the magnitude and direction of vector A. The magnitude is 8 units, and the direction 34 degrees. Well, that wasn't so bad. Now, let's take two vectors and, following the same procedure, find the resultant. Once we resolve each vector into its components, and hence find its ordered pair, we simply add these ordered pairs to get the resultant. Vector A has a magnitude of 4 units and meets the horizontal at an angle of 20 degrees. Vector B is 5 units at an angle of 60 degrees. Once we find the ordered pairs for A and B, we can add them together to get the resultant. And we get ordered pairs by resolving vectors into their components. Starting with vector A, its horizontal component is the magnitude of A, cos theta, or 4 cos 20 degrees. With a calculator, we find that this equals 3.76 units. Vector A's vertical component is 4 times the sine of 20 degrees. This works out to 1.37 units. So we have the ordered pair for vector A, 3.76, 1.37. Now we follow the same procedure with vector B. Its horizontal component is 5 cos 60 degrees, which equals 2.50 units. And the vertical component is 5 sine 60 degrees, or 4.33 units. Adding the two ordered pairs, we get the resultant, 6.26, 5.70. The Pythagorean theorem gives us the magnitude of the resultant, 8.47 units. And the tangent ratio gives us the direction, 42.3 degrees from the horizontal. So, without a grid and with two vectors that didn't meet at a right angle, we were able to find the magnitude and direction of the resultant anyway. Knowing how to do this is a valuable tool when applying vectors to real-life situations where grids simply aren't available.
Geez, Charlie, I'm still not too sure about all this vector stuff.
Listen, Ed, if you don't start picking this up soon, I'm going to have to use force.
Force? Do you think we're ready for force, Charlie?